In this video, we will use the cross product to find the area of a parallelogram and triangle quickly. All right, so I want to begin with the picture. So let's say that I have a vector u and I have a vector v. And let's draw some more parallel lines to turn this into a parallelogram. So where the head of u is, I'm going to draw a dashed parallel line to the vector v. And then where the head of v is, I'll draw a line that's parallel to u to sort of make our parallelogram. Okay, so I want to figure out the area of that parallelogram. In fact, let me label the vertices. So let's just call this A, vertex B, vertex C, vertex D. Find the area of that parallelogram A, B, C, D. So the formula for the area of a parallelogram is you take the base length. So you take the length of the base and you multiply it by the perpendicular height. Okay, so in my picture, I can see that the base is going to involve u, at least if I let u be the base side. So the base is going to be the length of u, in fact. And the height is, well, the height would be the perpendicular distance from, say, the head of v straight perpendicularly down like this. And if I call the angle between u and v theta, we know that that vertical distance would be the length of v times sine of theta. And that's going to be the height of this parallelogram. So the height is going to be the length of v times the sine of theta. But this looks familiar. This is the length of the cross product. So if my parallelogram is formed by these two vectors, I can find the area of the parallelogram, by taking the cross product of the two vectors and then just taking the length of that. Okay, so let's highlight this. So area of the parallelogram is equal to the length of u times the length of v times sine of theta, but that's just the length of the cross product. All right, next let's state the formula for the area of a triangle, because we can get that actually really quickly from this one. All right, so I've copied down that same picture from before, but let's make a triangle now by just connecting vertex D to vertex B. And let's say we want the area of the triangle ABD. All right, so we know that the area of a triangle is 1/2 times the base times the height. And the base and the height, well, we've already seen what those are. So the base is the length of u, the height is the length of v times sine theta. And overall, this is just going to be 1/2 times the length of the cross product. 1/2 times the length of u cross v. Okay, so I'm going to highlight this as well. The area of the triangle is 1/2 the length of u times the length of v times sine theta. And that is just 1/2 times the length of the cross product. All right, so let's use this to get the area of a triangle. So let's say we want to find the area of the triangle with the vertices P, Q, and R from the last video. In the last video, we did a different example involving these same vertices. And in the last video, in fact, we did all of the following. We took these vertices and we found these vectors u and v, where u, we let it be in the direction from P to Q. And then v was the vector that went from P to R. So we found those vectors. And we also took the cross product of u and v, and we got -3i hat, -10j hat, -6k hat. So all of this came from the last video. So if we want to find the area of that triangle, in fact, we can go ahead and draw that triangle in. Well, that triangle is sort of half of that parallelogram. I could extend my lines if I wanted to and make the parallelogram, and we're just getting half the area of that. And that's why this formula here is just half of the length of the cross product. Okay, so let's use that formula. So the area of our triangle, so the area of the triangle PQR is going to be 1/2 times the length of that cross product, the length of U cross V. All right, so now let's find that length. So we got 1/2. I know the length is going to be a big square root, and we'll get the first component squared, I component squared, plus the J component squared, plus the K component squared. Okay, so that square root ends up being, we get 9 plus 36, which is 45, plus 100. So root 145, and then 2 in the denominator, and that's the area of the triangle. And that's really nice, because in practice, to get the area of a triangle like this, where all the vertices are actually in 3D space, we would need to pick one of the sides, find the length, and then let that be the base, and then somehow draw a perpendicular from the other vertex to that side and figure out how long that perpendicular height would be. And that seems a lot more complicated, especially in 3 dimensions, than just using a cross product like this. The cross product actually let us determine that area really quickly. So in terms of our goals, we have now used the cross product to get the areas of parallelograms and triangles. In the next video, we will look at an application of the cross product to the notion of torque, which shows up in physics.